So today we're going to cover Chapter 2, Section 3. We're going to be analyzing graphs of functions. So first thing we're going to do is try to figure out what the domain and the range of the graph are. And remember, the domain is your x values, and it's going to be all the values from left to right. The range are going to be all the values from the bottom to the top. We're going to be giving our answers in interval notation. When you have solid dots, remember those will be the brackets. When the open dots or the open circles, those will be parentheses. Now, we're also going to be identifying where our graph increases, where it decreases, and where it is constant. So when it's increasing, it'll be rising. Think of it like a positive slope. When it decreases, it's like a negative slope. It'll be falling. When it's a constant graph, it'll be a horizontal line. Again, we're going to be giving our answers in interval notation. The open dots, except if the graph stops or starts. So here though, for WebAssign tonight, for the increasing, decreasing, and constant, everything gets parentheses. Okay. However, the domain and the range is going to get the parentheses and the brackets. So remember, increasing, decreasing, constant gets only parentheses. If your graph does not have one of these three things, whether it doesn't increase or decrease or doesn't have a constant section, then you're going to type in the three letters DNE on WebAssign, which stands for does not exist. These three things, increasing, decreasing, constant, they all come from the domain. They're all x values. So let's go ahead and take a look at our first graph. And again, we're going to be finding domain, range, increasing, decreasing, and constant. So I'm going to go ahead and set this up underneath. I'm going to write the domain, range, increasing, decreasing, and then the constant section. Okay, so for the domain, remember this is from left to right. It is your x values. So what I want you to do is I want you to imagine that you're walking across the x-axis, and you're going to come and see what you encounter first. And I'm only looking for x coordinates. So as I'm walking along, my first x order pair, or my first coordinate, is going to be this order pair, which is going to be the order pair -3, 0. My domain are only the x's. Notice it's an open circle, so it'll be a parenthesis, -3. But then as I continue along, I still have x values here because I still have the graph up above here. And then it stops right here at this order pair, which is the order pair 2, 0. And again, remember, you're only using the x values. So this is going to go from -3 to 0, and both of them have the closed circle. The 0 gets a bracket because it was a solid circle. Now, as I continue walking along here, notice I've got a gap here. There is no graph here that has x coordinates. But when I go over here, right here at 2, this order pair 2, 3, that is this point of the open circle. So now my gap is the u, and then I'm going to open circle, and again it's the x value. And then notice the arrow indicates that this keeps on going. Now, this arrow, you have to imagine that in addition to going up, which is the direction it looks like it's pointing, but it's also eventually moving to the right as well, because this is like the side of a parabola, and eventually this is actually going up and out at the same time. So my domain, it's going to eventually cover the entire x-axis. So this is going to go to infinity. And that's my domain. My range, I'm going to imagine walking up the y-axis from bottom to top. So now I'm here and I'm walking up and I want to find my first y coordinate that I encounter. So as I come on up here, my first y is this order pair over here. And remember, we look at the y of the order pair. So that's going to be a 0. And it was an open circle, so parentheses. And now as I continue up my y-axis, my next point that I encounter is right here, and the y of that ordered pair was 2. And you can see right where it's hitting. It's hitting the y-axis at 2. So 2, and then this is a bracket because it was a closed circle. Now I have a little gap here with no y values, and then my next y value will come from this order pair over here. So I'm going to union this, and then it's an open circle, so a parenthesis, and then that y value is the 3, and then the arrow indicates that it goes to infinity. That is your domain and range. You have to put the brackets and the parentheses based on the solid circle or the open circle. Now, the increasing, decreasing constant comes from the domain. Now, again, what we're going to look at, don't look at the arrows. We're looking at like the positive and the negative slope. All right. So on my graph here, these two pieces are both increasing sections. So this is rising from left to right, and so is this one. Again, don't pay attention to the arrow. The arrow here, it actually helped you, but just know, like for the next one, you see how this arrow looks like it's pointing down, and you might think it's decreasing, but it's actually increasing. Okay, so don't pay attention to the arrows for increasing, decreasing, and constant. All right.
What sections are on that?
For this one, for the increasing, all you're going to do is rewrite those two from the domain. So my increasing is -3 to 0, and then 2 to infinity. This is DNE. There is no decreasing portion of the graph, and there is no straight horizontal line, so no constant as well. Okay, for the next one. Now, this arrow that's here, you need to realize that it's actually going down, and it's also eventually pointing to the left. So they're both going to negative infinity as far as that arrow goes. So now for the domain on this one, so again, our domain is going to be the first thing we encounter as we're walking left to right. So the first thing I run into is the arrow. So that's going to be negative infinity. And then it stops here at the -2. And it's an open circle, so it's a parentheses. Then I have the little gap here. And then my next x value is right here at the 1. So it starts up again. So union, bracket with the 1, and then it goes to the 2. Parenthesis, it's an open circle. The range, we go bottom to top. So we start down here. The first y I encounter is the arrow. So that's going to be negative infinity. And then as it keeps on going, it stops here at the 0. And then it has a little gap. And then it starts up again at the 1. And then it continues and it stops at the 2. So it's going to be parenthesis 1. And actually bracket 1. And then parenthesis 2. Because the 1 has a closed circle, but the 2 has an open circle. And now both of these are increasing. So they're both rising from left to right. So they're both increasing intervals. So increasing, and again, I'm just going to go ahead and rewrite my domain. And it's negative infinity to -2, and then 1, 2, all parentheses. Both the decreasing and the constant are DNE, does not exist. The next one, this one has all three. So again, still doing the same thing, domain. And again, we're walking across the graph. So the first thing we encounter is this arrow. So it's negative infinity, because in addition to pointing up, it's also pointing to the left, because you got to remember the parabola gets wider and wider. And this is like half of a parabola. Then the next x coordinate that I encounter is right here at the -3, the open circle. So that's a parenthesis. Then it's got a little gap right here between -3 and -2. Starts up again at -2 with a solid circle. So it's a bracket. And then it continues on and it stops at 1 with an open circle. So it's a parenthesis. Then it's got a gap again. So that's the next union. And then it starts again at +3, open circle, so it's a parenthesis, and then the arrow indicates going to infinity. For my range, I'm going bottom to top. So as I walk up, my first y that I encounter is +1 with a solid line. So that's going to be a bracket. And then notice, now you may think, oh, it looks like there's a gap there, but it's not. Because if you look over here to the side, where this gap apparently looks like, this graph is continuing on to infinity. So no gaps here, it goes right on to infinity. So now let's do the increasing, decreasing, and constant. And again, remember this comes from the domain. And again, I've got 3 sections for the domain. So all 3 are going to go to each one of these increasing, decreasing, and constant. So let's go ahead and take a look at which piece is which. So for the increasing piece, this is the one that I've already highlighted here in purple. It's this one. This is the increasing. This one is falling. This is the decrease. And then the horizontal line is the constant. So my decreasing is the -infinity to the -3. My increasing is the 3 to infinity. And my constant is the -2, 1. And again, all parentheses here. All right, then same thing. Domain range, increasing, decreasing, constant. Now they also want us to find some values of the function using the graph. We don't have an equation to plug 0 into, but we can look to see where x equals 0 and what the corresponding y value is. So x equals 0 is going to be right here. And if I follow it down, the corresponding y for 0 is going to be -4. And then if I do +3 for the x, which is right here, it's the order pair 3, 0. So my y value is 0. Now let's do domain. So as I walk across, the first x value I encounter is right here at -2. And it's an open circle, so it's a parenthesis. And then as I walk along, my next ending x value here is going to be 0. And it's a solid circle, so it's a bracket. Now I have a little gap here before my next x value, which is +1. And it's an open circle, so it's a parenthesis. And then now remember, as I move along here, this arrow not only is going up, it's also slowly creeping to the right. So it goes to infinity. For the range, again, bottom to top. So my first y value I encounter is right here at -4. So -4 closed circle, so it's a bracket. And notice this one is already filled in the gap. And then if you look over here, this one takes over and it goes to infinity. So no gaps, it goes right from -4. And again, sort of think of like the lines merging together, and there is no gaps going bottom to top. Now the increasing, so this line is falling from left to right, so this is the decreasing portion, and this one is rising from left to right. So that's the increasing portion. So my increasing interval is going to be from 1 to infinity. My decreasing is going to be from -2 to 0. And then there is no constant, so dne. For number 5, this is actually the graph of a parabola. And if you remember yesterday, the domain for all parabolas is all real numbers. Notice the arrows on the ends. Again, I know they look like they're pointing up, but they're actually creeping to the left on this side, and this one's going up, but it's going to the right. Because remember, your parabola, this U shape, is going to eventually get bigger and bigger and bigger, eventually as you keep creating ordered pairs. So the parabola, the domain, is always all real numbers. Now, my f of 0, notice this ordered pair here for the y is 1. So f of 0 is 1. My domain, again, because those arrows are going to keep going wider and wider and eventually cover the entire x-axis, the domain is all real numbers. -infinity to positive infinity. The range, again, bottom to top. So the first y value I encounter is 1 with a bracket, and it goes to infinity. Those arrows are pointing up. Yes. Okay, so the range here goes from 1 to infinity. And notice this side of my graph is the decrease, and this is the increase. Don't look at the arrows, because you may think that left side is increasing because it's pointing up, but the line is slanting down. So this one, the increase, is that right side of the graph is going to be 0 to infinity, and the decreasing is going to be from -infinity to 0. There is no constant on this graph, so the constant is dne. And then the last one, again, let's evaluate when x equals -3, and it's this ordered pair right here. So it's going to be, the y value will be 1. Then when we want to find where x equals 1 is right here. So the y value for that ordered pair is also 1. So both of them are 1. So now let's do the domain. And again, we're walking left to right. So as I walk here, the first point I encounter is right here at -5. And notice it's an open circle, so a parenthesis. And then as I walk along, the graph stops here at -3 with a bracket. Then I got a little gap here, so that's going to be my union. And then it starts up again at -1, and then it goes to +1. And -1 gets a parenthesis, +1 gets a bracket. And then again, it's got a little gap, and then it starts up again at +3. So union, +3 is open circle. And then I know the arrow is pointing down, but again, in addition to going down, it's also slowly creeping to the right, which is the negative, it's the positive infinity. The range, bottom to top. So as I go up the graph, the first point that I encounter is going to be the arrow here. So this is pointing to -infinity. And then as I go up, no gaps here. And then the highest the graph gets is at the 3. The increasing portion of my graph is going to be this section right here. This will be decreasing, and this will be decreasing. So for the increasing, that's going to be -1 to +1, parentheses around. Don't worry about brackets. And then for the decreasing portion, that'll be from -5 to -3, and then 3 to infinity. And again, you don't need a union for increasing, decreasing constant. Okay. Even and odd functions. An even function will occur when you plug in a -x for x. And once you plug it in and you simplify it down, if the negative goes away and it simplifies back to the original, it's an even function, and it's symmetric to the y-axis. When it's an odd function, what will occur when you plug in the -x? What happens is the function everything goes to opposite signs. So you're going to plug in a -x, and if each term changes signs and goes to its opposite, then you would say it's an odd function and it's symmetric to the origin. If only part of your function changes, then you're going to say that it's neither and it has no symmetry. So x-axis symmetry will occur when y is raised to an even power or in absolute value. A function cannot have x-axis symmetry. If it does, then the x's repeat. You do your vertical line test. So let's try some examples. Now, on here, I'm going to determine if the function is even, odd, or neither, and I'm also going to describe the symmetry. So in order to determine if it's even or odd, I'm going to take and plug in -x. So I'm going to change both of these x's and make them negative, and then simplify it. So I'm going to plug in a -x, and then I'm going to cube it, and then here a -x for the x. Once I simplify -x to the third, it just becomes -x to the third. And then this one, the negative makes the x become positive. Notice both signs are opposites of the original. So this is opposite of my original function. So because it's opposite of the original function, it's an odd function, and it's going to be symmetric to the origin. For number 8, I'm doing exactly the same thing, and then I'm going to simplify it. So I'm plugging in a -x every place that I see x. So -x, and I have to square it. Once I simplify that, it turns positive, and notice it went back to the original. So because it went back to the original, it is an even function, and you're going to say that it's symmetric to the y-axis. The last one, again, plug in a -x for the x. -3 times -x. This will simplify to positive 3x. But notice only the x term changed to opposite sign. So this one is neither. No symmetry here. All right, more. Same thing, even, odd, or neither, and then determine the symmetry. So again, I'm going to plug in a -x for every spot that I see an x. So anytime you have a negative number raised or a negative variable raised to an even exponent, it turns positive. And this just becomes a positive x squared. And notice this went back to the original. So when it simplifies to the original, it's an even function, and it's got y-axis symmetry. The next one, again, plug in a -x. 2 times -x to the third plus 3 times -x. -x to the third just stays -x to the third. And then I can multiply it by the 2, so it becomes a -2x to the third, and this becomes a -3x. Notice this is opposite of the original. So this tells me this is an odd function and it's symmetric to the origin. So when it's even, y-axis symmetry. When it's odd, symmetric to the origin. Think OO if that helps. And then if it doesn't totally turn back to the original or have everything opposite signs, then it's going to be neither. And then the last thing we need to cover are finding the zeros of a function. We've already done this. Now, when you see this on a standardized test, they could ask this question multiple different ways. The zeros of the function, when we're setting it equal to 0, what these are also finding are our x-intercepts. The instructions might also say find the roots or find the solutions. So finding zeros, finding roots, finding solutions, the process is the same for all of these instructions. We set our function equal to 0, and then we solve for x. So when it's a quadratic equation, we're going to get 2 answers because it'll usually have 2 x-intercepts, unless your vertex is sitting on the x-axis, and we're going to see that coming up. But let's go ahead and do the first one. So in order to find the zeros, I'm setting my function equal to 0, and this one I can factor. Now I could guess and test because the factors of 2 are just 2 and 1, and the factors of 1 are just 1 and 1, but I'll factor it by grouping. So I'm looking for 2 numbers that multiply to give me 2, but who add to give me -3. And those 2 numbers are going to be -1 and -2. So 2x squared minus 2x minus 1x plus 1. Make your groups. Red group, blue group. GCF of red is 2x. X minus 1 remains. GCF of blue will be -1. And again, set these 2 GCFs back together in a binomial. And then the one that's in common. Now set each of the binomials equal to 0. So 2x minus 1 equals 0. And x minus 1 equals 0. Add 1. 2x equals 1. Divide by 2. And x equals 1/2. Add 1, x equals 1. Now, moving forward, when they ask you to find zeros or x-intercepts, you'll write them as ordered pairs. However, in WebAssign tonight, they're just going to tell you to type in 1/2, comma 1. Okay, so you would just put them separated by a comma. But if it ever asks you as an ordered pair, it would be 1/2, comma 0 and 1, comma 0. But WebAssign just wants you to separate the solutions with a comma if there's more than one. And then the last one, all we're doing is setting this fraction equal to 0. So 2x plus 5 over x plus 5 equals 0. I'm going to multiply both sides by x plus 5. It'll cancel the denominator. And now I just have to solve 2x plus 5 equals 0. And then subtract 5. 2x equals -5, divide by 2, and x equals -5 over 2. And in WebAssign, you're just going to enter -5 over 2. But if you're ever asked for the order pair for this x-intercept, it would be -5, comma 0. And that is it for your notes on section 2.3.